chapter 16 is where we first start looking at probability. So 16.1 is only going to talk about really about sample spaces, looking at how many different things or what are the different outcomes that can happen. In the rest of the sections, we'll start looking at how we can count up how many outcomes there are. But in this one, we're just kind of listing them or thinking about all the things that can happen. So probability is we're trying to give a number or quantify uncertainty. It doesn't mean that I know what will happen. Like, for instance, if I flip a coin, so most people are pretty familiar that it's got a 50-50 chance of landing, or a 1/2 probability. So 50-50 chance of landing heads or tails. That doesn't mean if I flip it once, it'll go heads, it'll automatically go tails the next time. But I'm trying to give a number to, and we'll look at this more later, but what would happen if I did that a whole bunch of times, maybe millions of times, is the theoretical probability. Or in these ones where we have a sample space that's not infinite, what's nice is I know that there's only two things that can happen when I flip a coin. It could go heads or it could go tails. So there's a random experiment. We don't know what's going to happen. I know there's only two outcomes, and say getting tails is one of those outcomes. So automatically I can say that it has a 1 out of 2 probability. So we'll get into the rest of that later, but the idea is random experiment. We don't know what's going to happen. We're trying to eventually assign a number to these things. So two things are important here. The set of all the possible outcomes is called the sample space. And then an event is whatever we define it to be. So for flipping a coin, the event could be flip the coin. Do you get heads or tails? Rolling a dice could be an event. Shooting a free throw and seeing if you make it or if you miss could be an event. So we're going to do a number of events, and the sample space is all the different things that could happen. All right, so our notation, getting into that, is going to be S will be how we list the sample space. And N is saying the size of the sample space, or N stands for number, so the number of things in the sample space. So let's think of a somewhat easy example of this. So let's say we flip a coin. We could get heads or tails. So if I want to list all the things in the sample space, and a lot of times use this bracket set notation just for making a list. It just means this is a list of things. So what are all the possible outcomes? Well, I could get heads, or I could get tails. So if I want to write down S, the sample space, pretty short sample space, it only has 2 things in it. But if I want to say what N is then, the size of the sample space, then there's 1, 2 items. I could get heads or tails, so there's 2 possible outcomes. So when they're talking about sample size, S, or the sample space, S, and N is the number of things in the sample space. That's what they're referring to. So similar, let's say we toss a coin twice. So I could get heads, heads, I could get heads, tails, I could get tails, then heads, or I could get both tails. So then my sample space looks like this, and N is 4, because there's 4 different things that could happen. I could get both heads, heads, tails, so you can see that there's 4 things listed there. So for short sample spaces, it's nice to be able to write them out and just see what's going to happen. For larger ones, we might want to start coming up with some tricks where we can tell the number of items that will be in the sample space without having to write the whole thing out. Okay, so another example, when rolling a pair of dice. So a lot of times in a lot of games, all you care about is the total, the sum of the 2 dice. And so that'll make your sample space a little shorter, because notice, let's say I roll a 2 and a 5. So my sum, or my total, is 7. Let's say on a different turn, I roll a 3 and a 4. So my sum is also 7. So if I'm writing down my sample space to be the sum that you get, I don't have to list this and this as 2 separate outcomes, because all I really care about is the sum, and they both got me 7. If I'm listing what happened to each dice, it'll be a much longer list. So let's think, if I'm writing out the sample space of just the sum, what could happen? So the lowest total I could get would be 2, right? If I roll a 1 and a 1. I could get a 2 and a 1. Really, we could get any combination up to, what's the highest thing you can roll on a dice? If I get 6 and 6, I could do 12. So there, the sample space is just the numbers 2 through 12, which is what? 10 different numbers? If we're trying to come up with n, the sample size of that. So that shortens it a bit. If I want to write down every possible outcome, notice that will be a little longer. So here's our sample space, same thing we just came up with. All the different sums you can get from 2 dice. Now here's what it looks like to write down your sample space being what actually happened to each dice. And so notice there's 36 different outcomes here. I could start all the way from a 1 and a 1 and end up all the way at a 6 and a 6. So that's a lot larger of a sample space. And technically they drew the dice here just so we could see them, but this is still a list of things the same way as ours was. So it's a sample space, they're separated by commas that starts and ends there, and there's n equals 36 possible outcomes there. Okay, so here's another interesting one. 5 candidates, A, B, C, D, and E, are running in an election. The top 3 vote getters are chosen as the president, vice president, and secretary in that order. So sometimes it's helpful to think about, does order matter? Like in the one where we had the sum of the dice, it didn't matter if you get a 3 and a 4 or a 4 and a 3, they still add up to 7. Here it looks like the order matters because whoever gets first is president, vice president, secretary. So say A, B, C, it means A is the president. If I took these same letters like B, A, C, that would change it because that would mean B is the president. Okay, so if I want to think about the sample space for this, and I can tell already this is probably kind of a long one, so maybe we don't want to write them all out, but we get the idea that this is a possible outcome. I could have A, C, B, because notice that switches who's vice president and secretary. I could have C-A-B. Eventually I could get down to ones that don't even have A, B, and C, maybe C, D, and E or something at the very end. Or I could have E, D, and C. So just the idea, when they get to really long ones, and they'll tell you in the directions on the homework whether they expect you to write it out all the way or not. But when they get to these longer examples, they don't always have you write out the entire sample space. And so then what they're getting at here is the same thing we just said, A, B, and C, and B, A, C are different because this person's president, vice president, secretary, puts different people in different positions. Let's say if we were just making a committee or something, then if these 3 people are on the committee, who cares what order we put them in? But in this one, the order matters. And we'll get some more formal language for that later in the other sections. And so this one, they're even just telling you the sample size is 60. So they don't want you to write them all out, but the ... is a way of saying, okay, here's the pattern. I see what's happening. Like on the coins one, I see I could get heads, tails, ... I see the pattern without having to write them all out. So, and next chapter or next section, that's what we'll talk about, is coming up with the number on the larger ones. But we just want an idea of what the sample space looks like, because it can be different in very little ways. Like the dice one, if they say write down the sample space is the sum of the dice, then if the sample space is the sum of the dice, then all you need is the numbers 2 through 12. If the sample space is your actual outcomes of the dice, then you end up with that big list of 36 different things that can happen. And so you have to pay attention to the directions when they're telling you what the sample space is actually recording. Actually, a really good example of this, go to a page where we have room for it, is with the heads and tails on the coins. If I said that the sample space, we'll say we're flipping 2 coins here. So I could get heads, I could get heads, tails, I could get tails, heads, or I could get both tails. Alright, so here's a sample space where I recorded the outcomes of the coin flips. if they told you that your sample space, for instance, was just the number of heads that you flipped. So here I could flip 2 heads. Now, either of these cases are just 1 head, so I don't have to say that that's different, right? If I'm just recording the number of coins that flipped heads, this is 1 and this is also 1. And then for the tails, we got 0 heads. So notice both of these are describing the same thing. This one's telling you to actually write down what happened to the coins. This one, they're recording the sample space as the number of heads that you got when you flip the coins. So that's what I mean about being careful when you're doing the homework to the directions of what they're having you record, because usually this is a shorter sample space. So if one seems excessively long, pay attention to if you got their directions correct.